Thank you for joining us today. Padma Raghavan, the Vice Provost of Research and Professor of Computer Science and Computer Engineering here at Vanderbilt, will now begin the event. Go ahead, Padma.
Thank you, Natalie. Thank you all for joining us today for this event. I'm delighted to welcome my dear colleague, Dr. Margaret Martonosi, to Vanderbilt virtually. Dr. Martonosi is the Assistant Director of Computer and Information Science and Engineering at the National Science Foundation. While serving in this role, Dr. Martonosi is on leave from Princeton University, where she's the Hugh Trumbull Adams Professor of Computer Science. The CISE-Directorate at the National Science Foundation funds more than 75% of fundamental research and education in computing, communications, information sciences, and engineering at US universities. Margaret leads the development of strategy and programs at the Directorate to advance US leadership in this area. Most recently, these have led to the establishment of AI, Artificial Intelligence Institutes, and she's going to speak to us today about these and other forward-looking initiatives at the intersection of technology and people. Margaret is a prominent leader. She has conducted groundbreaking research, and she has developed a host of programs and professional activities to advance the national CISE community, including in particular those who historically do not participate at high levels in our field, those from underrepresented groups. Margaret's recent work is in quantum computing, but it really builds upon her deep and lasting contributions to traditional classical computer architectures and systems. She has been elected to the American Academy of Arts and the Sciences, and she's a fellow of the Association for Computing Machinery and the Institute of Electrical and Electronics Engineers, all for advancing power-efficient computer architecture and systems. I want to tell you a little bit more about her accomplishments. Most of you have heard about Moore's law, which is actually not a legal construct, nor is it a law of nature, but rather a design principle that the architecture of computer chips and their integrated circuits could be developed in a manner by which processor speeds would double every 18 months. As you know, there has been exponential growth in computer speeds derived from this framing, and we're all benefiting from it today. But this happened largely because the designs could drive more power, more electrical power into the circuits. In a landmark paper in 2000, Margaret was among the first to signal that this approach was going to soon hit a wall, the power wall, and that power dissipation and thermal issues would become a pivotal driver of future computer architectures and chip designs. Even more importantly, she developed along with her team a tool called Watch, sort of like the watch you wear, which models power implications in circuit design and layouts. And that was about 1,000 times faster than previously existing tools. And it was instrumental in jump-starting power-aware processor development. About 8 years later, when I started considering power-aware supercomputing in my lab, we first looked to Margaret's work, which has been very influential across the board. For example, with reduced power consumption by computer chips, it became possible to bring mobility to processing. Who doesn't want that? After all, you don't want to drain that battery. Then Margaret went on to lead a project to demonstrate mobility with sensor networks, where she and her team developed solar-powered, GPS-based, power-efficient tracking collars that were put on zebras in Kenya so that biologists could better study their movement. What can I say? Margaret even went on a safari to advance computer science. With that, I'll turn it over to Margaret. Margaret?
Wow, thank you so much for the kind introduction. I really appreciate that. I guess once you've gone on safari for computer science, the next step is to go to Washington. And so with that, let me share my screen. Can you see?
Yes.
Wonderful. So hello, everyone. My name's Margaret Martonosi. I really appreciate the kind introduction, and I really appreciate the time you're spending here today I know there's an awful lot of polls on our time these days, especially right now with students coming back to our universities and our kids going back to school. And so I appreciate you taking a couple hours out of your day to do this. As Padma mentioned, I am the first hat that I wear is that I've been a professor at Princeton since 1994. But in February, I took on a 4-year rotation to come into the National Science Foundation to lead the CISE-Directorate there. And NSF does these rotating positions, so I retain my tenure at Princeton. I keep advising students there, but I'm also leading the CISE-Directorate. And so it's a unique opportunity to go from one side of the research community to the other side in this role of hopefully advocacy for the important issues that we as a community are trying to tackle, especially right now. And as AD, as we call it, Assistant Director for CISE, in a normal year, I would have probably been visiting different campuses about once a month. And I had some of those kinds of seminar visits lined up when I started in February. But as you can imagine, by mid to late March, those were all canceled. And I took a couple weeks to ponder that and then came to the idea of these virtual campus visits. And basically, instead of being able to visit one university a month roughly, and maybe a dozen for the year, I've been able to visit 25 universities in this framework already, and there's more scheduled. So it's been a very rich and interactive way to learn from the community and to share ideas with the community. And I'm eager to hear what Vanderbilt has to say. So thank you very much. So with that, the way this typically works is I'm going to speak for about 40 minutes. I am not very good at fielding questions while I speak. So if you want to put them in the chat box, if they are urgent, I'll ask Padma or others to sort of flag me down, but otherwise put them in the chat or the Q&A, and then we'll have plenty of time, around 45 minutes, to talk through them and other questions later. And so with that, now we can get rolling. So, picture of a tree. This tree is actually about 100 feet behind me as I sit in my primary home in New Jersey. My husband and I very much enjoy this tree and the shade it gives us, but we've never actually met the person who planted it. And I think a lot of different cultures have this notion of one generation planting trees so that subsequent generations can benefit from it. And when I think about research, I think about it in that way. So when we as researchers decide on the next paper to write or the next proposal to write, or when we at NSF decide on a new program to start, we're basically deciding on trees we're going to plant so that 10, 20, 30 years in the future, there'll be some benefit, there'll be some shade. And likewise, the fact that we are able to be here virtually today is in some sense because of trees that were planted 10, 20, 30 years ago in high-speed networking and advanced graphics processing and other fields that let us sort of get to the point where virtual conferences like this are so easy to have. The other thing about this analogy, in addition to that long-term vision aspect, the other thing about it that applies to research is the notion of community. You rarely plant trees just for yourself. You're usually planting trees with other people and for other people. And that notion of community, I think, is never more important than it is right now as we face the challenges we're facing as a nation. So both of those ideas are very resonant to me. So to get more onto the researchy side of things, let me talk about a tree that was planted 20 years ago. This is just one example. And frankly, as CISE AD, one of my jobs is to be able to pull these kinds of stories out over and over and over again. So if you have a story like this, I would welcome it. I want to be able to tell as many of these kinds of long-term impact stories as NSF has, and there are many. So feel free to share with me a 3-minute video or some slides, and I will be using them too. This particular story is of the LLVM compiler infrastructure, which had its primary funding in a career award that was funded 20 years ago this year. And from that has come, as you'll see, a huge amount of different types of impact. If you are like me in the compiler and architecture part of our space, you probably have already used LLVM in your research. But for everyone else, if you've installed an app on an Android or Apple iPhone, you've probably also used LLVM. And so I'll let Vikram tell his story, and then we'll come back for the rest of the talk.
Margaret asked me to give a brief retrospective on the LLVM project. This project was primarily funded by NSF, and in particular by my NSF Career Award on techniques and applications of dynamic compilation. The project was started in the fall of 2000 at Illinois by my first PhD student, Chris Lantner, and me. Now, LLVM is not a compiler. This is a common misconception. Rather, LLVM is a compiler infrastructure, a toolkit for building compilers and compiler-based tools. The primary paper on LLVM, which appeared in CGO 2004, has become one of the most highly cited papers in programming languages. And notably, most of the other papers on this list are classics that appeared over 25 years before LLVM did. So what was the primary innovation in this paper? Compilers for static or so-called unmanaged programming languages have traditionally always compiled application source code to binary machine code, and that is what is shipped to end users, and no more changes are made. And this model has been used for over 50 years for all major programming languages. And LLVM, of course, itself can also be used in this way, but in fact, we carefully designed the LLVM compiler internal representation so it can also serve as a virtual instruction set, and which allows programs to be shipped in LLVM bitcode form to end users and then optimized for the end user's machine. And the key benefit of this is that the virtual instruction set enables far richer optimizations than native machine code instruction sets. Perhaps the most important commercial use of this is for Apple mobile apps, which are routinely shipped in LLVM bitcode form from app developers to the Apple App Store. And Apple takes advantage of this in a variety of ways, for example, installing single version rather than fat binaries, performing a variety of optimizations transparently on apps after they are shipped, and even migrating 32-bit apps to 64-bit processors for the Apple Watch in 2018. A number of major industry products have been based on LLVM, incorporating LLVM source code. Now, compilers themselves don't make money, but compilers are a critical part of the tool chain for hardware, and a number of different hardware products with hundreds of millions of dollars and even billions of dollars in revenue have depended heavily on LLVM. Perhaps the award I'm proudest of is that LLVM received the ACM Software System Award in 2013, which is given to one software system worldwide every year. In ongoing work in the HPVM project, we have extended LLVM, the virtual ISA, with data flow abstractions, which allow a single virtual object code program to be optimized and compiled for diverse parallel compute units, achieving both portability and performance. Thank you. Margaret?
Great, thank you, Vikram. Okay, so now we can dive in. For background, for maybe some early career folks, NSF was founded 70 years ago this spring in the aftermath of World War II to be the nation's all of science basic research agency. And so that all of science mission means that unlike, say, NIH, which focuses narrowly on human health, NSF is allowed and encouraged to span all the scientific areas. You can see the directorates here, and to look for opportunities that actually bridge between them. And you'll see that flowing through the talk as well. So CISE fits into this space alongside the other scientific endeavors as well. CISE's structure looks like this. We have 4 substructures within our directorate. 3 of them correspond to different parts of the research space. The 4th one, the Office of Advanced Cyberinfrastructure, or OAC, has this unique mission that, although it's organizationally within CISE, its mission is to provide advanced computing resources, and that's not just hardware, not just software, but also the people, the networking, the education, the sphere of resources, to not just computing, but to the full scientific field. And so OAC plus the quote unquote research divisions work together to span computing and information science and engineering overall. And then one of the things that I like to point out is the degree to which these divisional structures don't really convey the many broad initiatives that CISE does both across the full directorate and reaching out into other directorates. And so our flagship program, Expeditions in Computing, is an example of a CISE-wide program. And then in addition, there are many multi-directorate initiatives that CISE leads. Padma mentioned the National AI Research Institutes, whose rollout a couple of weeks ago was very exciting for us. There's also Secure and Trustworthy Cyberspace and these other large endeavors as well. And so we really try to be broad and deep in how we cover the space. By the numbers, here's what CISE looked like in the last fiscal year that's ended. And so this is the last year for which we have all the numbers. So in fiscal year 2019, the enacted budget for CISE was just under $1 billion, and just under 9,000 proposals came in the door. And from that, just over 2,000 awards were made. So for research grants, take out the travel grants and so forth. For research grants, that's around a 21% research grant success rate, award rate. And with that, we fund around 20,000 people, ranging from professors, postdocs, grad students, and undergrads. So as Padma mentioned, we have the extraordinary opportunity and responsibility to fund the vast majority of academic CS research in the US. So it gives us this extraordinary convening power with the full research community, but also the responsibility to make sure that the funding is available to follow up on the many, many opportunities that our community identifies as important for society. In fiscal year 2020, which is soon going to end, CISE operated for the first time with a budget over $1 billion. So 1.01 billion, we just ticked just above it. Fiscal year 21's budgeting process is underway, as you know. The president's budget request went into Congress in February, where the Senate and the House are now considering it. As you'll remember from high school or civics class, Congress has the power of the purse. So the budget request that the president puts in is one step in a longer process, and we're waiting to hear how Congress actually lands on it. But you can see that in this budget request, NSF as a whole was down, but CISE as a whole was up. And that tends to reflect the fact that CISE has important efforts in areas that are deemed to be national and societal priorities. Obviously, when you see NSF as a whole down and CISE up, it's also an indicator that we need to be good partners with the rest of our interdisciplinary directorates. So in essence, from that CISE by the numbers slide, coming back to the tree analogy, in essence, this is what NSF's job is. This is what CISE's job is. If you had $1 billion a year, and roughly speaking, we do, what research would you spend it on? What trees would you plant? And $1 billion sounds big, and it is, but you have to keep in mind the 9,000 proposals, the 20,000 people we want to fund, and that $1 billion needs to be spent in very strategic and careful ways in order to go in order to have as much impact as possible. So what I'm going to talk about today are some technical themes, some inflection points in our field and where we see things going. And then if you think about how to advance on technical themes, there's a number of different things we could talk about. We could talk about infrastructure to help. We could talk about partnerships. We could talk about people. I will weave infrastructure and partnerships into the technical part, but people I'm going to pull out and have it be its own part of the talk. And then I'll go through some recent events, COVID++, and NSF impacts and responses. And then, as I said, solid 45 minutes for Q&A. So in order to sort of organize CISE's thinking about the way forward, we've identified these three themes. This is not to say that these are kind of narrow pathways through the space. These are rather to say that these are organizational umbrellas to pull together the ideas that are important across our full space. And I would put forward that everyone, in the CISE research community should be able to find themselves under one of these umbrellas, but probably actually under 2 or 3 of them. And so I'll talk about each one in a little bit more detail. The first theme that I want to talk about is CISE in the post-war world and the seismic shift. And yes, there is a pun there, seismic shift. The basic idea here is to acknowledge the degree to which the end of Dennard scaling and the slowing of Moore's law has fundamentally reshaped the technology, the underlying hardware and hardware design methods of our field. At the same time, there's massive application trends that are reshaping computing as well. And what we're seeing is that there's been just fundamental changes in the kinds of computer systems we're building and we will build. You can already see it in your phone and in your laptop. Increasing use of heterogeneous and specialized parallelism, accelerators, everywhere from embedded systems up to data centers and so forth. And you could look at me and you know how Padma introduced me. So you could say, well, she's an architect, so she's just sort of pitching her own research idea. But here's the thing that I really want to stress is this is changing everything. And so this is not just my research idea. This is not just hardware. This is changing everything because the way that you design for heterogeneous and specialized parallelism, the way you program, the way you map for it is fundamentally different. So it's not just hardware 2.0, but also software 2.0. And I would argue curriculum 2.0 as well. So why do I have this picture on this slide? This is actually a picture of the Water Pocket Fold region of Utah. And I love it because it's a case of where there used to be very horizontal sedimentary layers. And then due to seismic forces, they got uplifted and tilted. And I see that happening in our field now too, that we got very used to this idea of sort of transistors, circuits, architecture, compilers, and so forth, the layers in a nice horizontal stack. And yet these days, we are increasingly seeing things like I'm programming to TensorFlow and it's compiled straight down to accelerators without going neatly through the stack as we used to view it. And so one of the big inflection points that our field is facing is this notion of a seismic shift in the layering and the design processes. So what are we doing about that? CISE has taken a range of actions in response to the seismic shift here. So one is that within our core programs, there's a new cluster called Foundations of Emerging Technologies. So if you have an idea about a new technology, whether it's quantum, whether it's DNA storage, whatever, this is a new home for you to send into our core solicitations. A second thing that CISE is doing about it is the Principles and Practice of Scalable Systems, or PPOS program, that had its first deadline in April of this year, and it will have subsequent deadlines every January for the next few years. The idea of PPOS is to bring researchers together across those different traditional layers to identify new ways forward. So it might be a programming languages person with a technology person. It might be a machine learning person with an architect to sort of span those layers. One of the things that's exciting to me is the degree to which this is a case of responsibility meets opportunity. So on the one hand, the Moore-Dennard scaling trends, we can't sort of change them easily, but what we can do is take this moment, this time of sort of assessing those trends and turn it into an opportunity to rethink things. If we're building deeply heterogeneous and specialized systems, they're much harder to verify. They're much harder to show that they are secure. They're much harder to port software from one system to another. So it calls for a reinvention. It's an opportunity for reinvention of many other parts of the stack while we're at it. So we could come up with more with specification layers that go beyond traditional instruction set architectures in terms of their ability to be verifiable, to be proven secure, and so forth. So basically opportunities to think beyond where we have been for the past 50 years. Another example is our QCIS Faculty Fellows Program, which basically says in the quantum space, there's a need for computer scientists to come in and bring their traditional, say, algorithms or programming languages kinds of expertise, bring that to bear on quantum systems. QCIS provides 3 years of bridge funding to CS departments who are willing to hire an early career faculty member in this topic area. And the last place where you can see this seismic shift playing out is in terms of the wireless space, which is very clearly being impacted by Moore-Dennard effects. And so our efforts to create next generation test beds to test out wireless protocols at scale is another example of this. The second technical theme I refer to as the transcendence of artificial intelligence, the transcendence of AI. And I use that word transcendence very purposefully because, as we all know on this Zoom, AI didn't just sort of poof out in the past few years. AI is almost as old as electronic programming, as electronic computing itself, right? So what's happened lately is a couple things. So one thing is that AI now has reached a point where the combination of effective algorithms with the availability and suitability of large-scale data, with the convergence of very high-end compute capabilities, it's that full convergence across our field that's actually allowed AI to advance as it has lately. The second thing is that in the process of these convergent advances, AI is no longer sort of a subfield that can be easily sort of cordoned off, but it rather transcends many different scientific disciplines and brings in many of us in different ways. So NSF already invests over $500 million in AI annually. This pie chart shows that CISE actually is not surprisingly, the largest funder of AI research at NSF with over $300 million, and then the other directorates kick in heavily as well. This blue box, you'll see a couple of them on slides. They represent cases where I'm pulling out numbers from the president's budget request. And again, keep in mind that that president's budget request goes through Congress before it becomes an actual appropriation. But in the president's budget request, one of the reasons why CISE was up when the rest of NSF was down was due to a significant plus up in AI topic areas, as you can see, requested. There's many different ways to look at AI funding. And so one of the things I want to stress is that while the AI institutes are exciting, and they've certainly been in the news over the past month, actually a lot of funding is in the core and goes to a much broader set of universities, researchers, and topic areas. So this is fiscal year 2019 data. So from the core, CISE alone funds almost $130 million of core AI funding. And then there's also these, and that you can think about that as sort of the foundational elements of AI. But then there's all the places where AI emerges in other topic areas, whether it's cyber-physical systems, where I know Vanderbilt is very strong, harnessing the data revolution, one of the NSF big ideas, and so on and so forth. You can see the numbers here. This is not a complete list. This is kind of what we could fit on a slide without it being too dazzling. And now here's the other thing, is how it's an all of NSF aspect to really fan out across these topic areas and to pull in money across the directorates towards this. So this is an all of NSF push. And it really, I think, shows that transcendence. But the National AI Research Institutes, which were announced the first round on August 26th, have certainly generated excitement. They came out of discussions that happened just last summer, actually, and the idea was to create a set of national hubs where academic researchers, government, industry, and nonprofits could work together to advance AI research and education, and quite frankly, to make sure that it remained as fun as possible and as impactful as possible to be an academic AI researcher so that we can keep those people in the academic workforce, and so we can train the next generation of AI workforce, our students. So with that as sort of the overall goal, the basic gist of these is $20 million per center over 5 years, per institute over 5 years. And the first solicitation had these 6 themes that you can see here, 4 of which were use inspired, for example, precision agriculture, and 2 of which were foundational and cross-cutting. The other thing about the first round of institutes was that they were an interagency partnership. You can see the different logos down here of the different agencies, and I specifically want to acknowledge the wonderful partners we have in the US Department of Agriculture. When we got so many good precision agriculture proposals, they changed their plan and funded 2 instead of 1. Anyone who knows me might remember that I'm a avid state bagger. I have visited all 50 states, And I love keeping track of, you know, which states I have camped in, which states I have swum in. And so I'm now applying my state bagging to AI research institutes. This map shows that with those initial institutes announced a couple weeks ago, we already cover nearly half the states in the country, either with the lead institutions, which are shown here as stars, or with their principal partners, the funded partners, or with other industry partners and collaborators, which are shown in circles. And so you can see huge swaths of the country that are engaged in the AI research institutes after just one round. So that's great. But wait, there's more. The fiscal year 21 solicitation, the new solicitation, went live the same week that the previous first round awards were announced. And in this case, there's a plan to launch new institutes, again, with the crosscut of use-inspired and foundational research. This time, in addition to our interagency partners, we also have industry partners that have signed up for particular themes that are of interest to them. And if you are interested in learning more about the AI Research Institutes, I would encourage you to tune in, register and then tune in for a program webinar that's going to happen very soon, September 21st. You can find more info on the NSF webpage. So I've talked about core AI funding, and I've talked about the AI Research Institutes funding. And in addition, I want to talk about some AI partnerships that are particularly targeted in different ways. So these are partnerships either with other agencies like DARPA, or with companies like Intel and Amazon, or with nonprofits like Simons and Partnership on AI. And across all of these, what you can see is a real movement from the notion of sort of AI for accuracy and efficiency only to these broader and deeply important metrics around AI in society, fairness, ethics, accountability, and transparency in our AI. And it really permeates much of what we do. And last but not least, you might be surprised to see this here, but this is an example of an infrastructure project, a sensor network that has among its attributes the notion of AI at the edge. So basically edge-based processing, both to improve the accuracy of the sensing and also to improve the energy efficiency of the sensing. Why am I showing this here? Well, one big reason why is because I want to show another way that we can fund important research, and that's through NSF's infrastructure programs. In this case, this particular award was made through NSF's mid-scale research infrastructure program. You can see that the award was for 3 years for $9 million. And so I want to highlight the fact that mid-scale is not small. Mid-scale is only mid-scale relative to, say, building a telescope facility in Hawaii. For most of us, the range of mid-scale in these programs is quite ample. Namely, mid-scale level 1 goes from $6 to $20 million, and mid-scale level 2 goes from 20 to 75 million. The second thing that I like to highlight here is to think broadly about what infrastructure is. We in CISE tend to think about infrastructure as something we could hold, like a sensor network, gadgets. Software is infrastructure, data is infrastructure. You heard Vikram Adve refer to LLVM as infrastructure. We know that data repositories, for example, what's the next ImageNet or the next 100 ImageNets that we will need to advance certain parts of our field. So software and data are infrastructure, and if you can articulate a broad national need that for such infrastructure, then these kinds of programs are very much in scope for CISE research, and I hope you will take a look at them and consider proposing to them as well. So the last technical theme is quite broad, and it encompasses many different aspects of our fields, namely CISE's socio-technical frontier. And as with the other ones, I think we've really reached an inflection point here that CISE has always had human aspects to it, but over the past 20 years, that socio-technical frontier has become very prominent in so many different aspects of what we do at all levels and in many forms. So there's things like robotics and smart connected health devices, but there's also things like advanced wireless and the digital divide. And CISE has, over the past year, undertaken a set of workshops with our partner directorate, the Social, Behavioral, and Economic Sciences, SBE Directorate, to look ahead towards future investments with three main themes in mind, namely reducing disparities, so that's health, education, bias. It's the trustworthiness of the information ecosystem, and it's empowering and diversifying the technical workforce. This is not to say that these are the only three themes we could focus on, but these are the three themes that the workshop focused on. And as I had said in other parts of this talk, I think this is another case where the inflection point points to responsibility meeting opportunity. We know that our systems are used in many societally impactful ways that warrant us as designers and as researchers thinking carefully about that societal impact. So that's our responsibility. As part of the opportunity, this gives us the chance to reshape those computations to bake in the important notions earlier in the processes and with novel techniques. Another example of sort of the socio-technical frontier has to do with connectivity. And here what I'm showing is the Platforms for Advanced Wireless Research map. So the Powder platform here in Utah is up and running. And there's other platforms on the East Coast that are either running or will soon. And these are intended to be test beds where a researcher can bring in their algorithm, their protocol, their software, and test it at scale for next generation wireless. The other thing I'll note, and we were super excited about, is the latest solicitation of power was all around affordable rural broadband. And we were able to give out seed funding. We were thinking initially of funding one awardee period. What we decided to do instead was to fund 2 awardees for a year to develop their ideas further. And so University of Nebraska and Iowa State University are doing seed projects towards this power platform for affordable wireless. Affordable rural broadband. Okay, so here are the technical themes. And as I mentioned, there's a question of how do you move on technical themes? How do you get there? So budget and program priorities are a key part of that. Infrastructure, I've already mentioned, is a key part of that. Strategic partnerships that let us leverage funds and identify important use-inspired research areas are another part of that. And then the people issue is important enough that it gets its own bullet here, and it gets its own couple of slides going forward. And there's an awful lot of different people issues I could talk about. Here's one. If you look at the most recent CRA Talby survey, what you'll see is that women represent about 20% of the US CS PhD graduates. And together these racial and ethnic demographics of African Americans, Hispanics, and Native Americans together represent around 3% of US CS PhD graduates. And so if you take those numbers and you compare them to the US population and you do the math, what you get to is that we as a field are missing around 70% of the US population's talents. We are trying to advance on really important societal needs using only about 1/3 of our population. And clearly, CISE has long been committed to the idea of fostering the careers of a diverse set of researchers. So the question is, how can we move the needle on these important issues today? One of the things that I'm trying to get the word out about is our BPC pilot, our Broadening Participation in Computing pilot. We're in year 2 of a 3-year pilot. And the idea here is that many of us have worked for a long time on different aspects of BPC activities. Some have worked so hard on them that they've developed deep expertise, and others have worked less so. So we have sort of a range of different efforts and expertise levels. The goal is to really push together to move the needle together. And we do that by the following idea. We're asking individual PIs to include a BPC plan with all of their medium or large proposals. And we're asking those BPC plans, in many cases, we're encouraging them to fit into either departmental BPC plans or into existing areas of national expertise so that we can push together on these things. The mental model that I always have is of the the training sleds that football players use, where if you just pushed on it as one person, it probably wouldn't go anywhere, certainly not if I did. But if the whole offensive line pushes together, the training sled moves. So we're trying to push together. So one of the things that NSF has funded is the bpcnet.org website, which includes a range of resources for PIs. Some of them are departmental resources to help departments write their own BPC plan, and others are broader national expertise resources, such as opportunities provided by CRA, NCWIT, CASI, and others. And the idea is that you as a PI can pick something out of these menu of resources and say that's where you're going to push, but working with your department, working with these larger organizations. The dates for different workshops here have passed, but there's plans to have more of these virtual workshops going forward. So I really encourage you to keep an eye out for the next round of dates when they're set. And I think the last thing I'll say is that over the past 6 months, our nation has gone through a lot of challenging discussions about race, about inclusion, about inequities in our society. And many universities, many departments have written statements of commitment regarding that. I view a department BPC plan as one way to take those statements of fairness and inclusion and turn them into action. And so I hope you will think about this as a chance to work on this in a very concrete way and to work with your broader CISE community. So NSF has also taken steps to stop harassment. In particular, in 2018, the National Academies issued a report that gave recommendations to universities and also recommendations to science agencies like NSF. NSF took the recommendations and has changed the terms and conditions that are applied to every grant or contract that you receive. And in particular, it asks universities to inform us when a PI has been found responsible or placed on administrative leave for the kinds of behaviors that are listed here. There's an FAQ about this, and there's a portal for reporting things. I just wanted to share the information about that. I close with highlighting a few Dear Colleague letters, or DCLs. Hopefully by now you've heard about a lot of these, but just further attempt to get the word out. So one DCL that we put out a couple months ago has to do with CRII and the career awards. And so the idea here is, first of all, encouraging our early career faculty members to submit their first career proposal earlier. We have 25 years of data on career proposals, and some of that data shows that year by year, faculty are waiting a little bit longer before they do their first career submission. Also in that data repository, we have data that shows that the people who do try earlier have a similar success rate to the people who wait and have their first attempt be later. So our encouragement is simply to say, if the success rates are similar, we hope you will try for a career award earlier, because then it can actually catalyze your early research instead of being something that you get just as you're about to get tenure for research that you managed to do through funding other than career. The other thing in this DCL is a clarification of the CRII program, namely that some people were starting to view it as something everyone did on their way into the career proposal. It's not intended to be that. It was never intended to be that. It was intended to provide sort of an even playing field for researchers who happen to get smaller startup packages, either because of their institution or because of the type of position they were in. And so there's FAQs about that. And we actually just had a CRII webinar yesterday, and I believe that'll be recorded and available for people to watch. The other Dear Colleague letter that went out represented literally years of discussion. We are happy to have landed where we have, which is that CISE has signaled that we are removing deadlines for proposals in our core small category. And so what this means is that effective October 1st, so with the new fiscal year, you can send in a core small proposal whenever you want, whenever it's ready. And the idea for this is it's motivated by several things. So first of all, it was clear the community wanted it. We had survey data that showed that was overwhelmingly the case. It allows for considerable technical nimbleness, I would say. When you have an idea, you can write it up and send it in. So if you had an idea about COVID or about pandemics, you could write it up and send it in when you have it. You don't have to wait for the next fall deadline. Second of all, we think this will be a very humane thing for your budget offices, your sponsored research offices that were often overwhelmed around the time of the CISE core small deadline with essentially a full faculty trying to aim at this one proposal deadline. And additionally, although it wasn't part of our decision process, I will say that given all the uncertainties that we have this fall, it gives me some comfort to know that you folks will not have to have a core small deadline in the midst of your fall semester calendar. If spring is the right time for you to write your proposals, spring is when you can write them. And I'm happy to field more questions about this during the Q&A. So just to close, this is a slide that has changed a lot over the 6 months that I've been using it. But it tries to be a scorecard that summarizes the different ways that the events of the past 7 months have really affected the community and therefore, and also how NSF has responded. So whether that's emergency postdoc programs like CI Fellows 2020, budget flexibilities, pivoting essentially seamlessly to virtual review panels, which have been happening all year, deadline extensions where we were able to, and so forth. I was really impressed and proud of how NSF responded to the challenges, and I was really impressed and proud with how the researchers have responded to the challenges. Many of our community are engaging in rapids to explore COVID-related research. There's a lot we don't know yet. We're still watching to learn more. I always put in a plug to join us. This picture was actually taken at a CISE all hands meeting just before we went virtual, so it's becoming a collector's item. But please do join us. Program officers serve virtually right now by telework, so there are unique geographic opportunities now more than ever. And I'm happy to field questions about that. And so with that, here's a few discussion starters that I have in general, but I'm going to stop sharing my screen in a moment and go back to gallery view so I can see more of you. And I'm happy to field questions. Thanks very much for your attention.
Thank you, Margaret, for that terrific talk. I know you've been at meetings all day. Maybe you want to catch your breath and get a sip of water, because here we are for another hour with you, and we're looking forward to it. So
I'm going to close my door. There's some noise outside. Okay, go.
Great. So how's Washington after Kenya? And I won't make you answer that. But really more seriously, right? How was it for you personally? Because, you know, you took over the leadership of CISE about a month before the pandemic hit. And, you know, and then you've seen what's happened with the pandemic. It's brought information technology and things such as surveillance and monitoring and privacy to the fore. How do you see this sort of shaping some of the directions going forward?
Yeah, sure. That's a great question. So first of all, I think as with many people who come to NSF, there's a sense of mission, sense of wanting to be an advocate. And certainly that's one of the things that drove me to choose to come to NSF, was a desire to be an advocate for the great research that our field does. And so COVID has only sort of strengthened the need for that advocacy. And so it really does feel like an important set of tasks to do. And I find that very heartening. Likewise, you can see many sort of research needs that come out of this. We've all heard about issues of contact tracing, for example. You mentioned privacy. Some of our field's work on privacy can be sort of drawn into that. I wouldn't say ready-made, but there are many things that our field has done over the years that are seeing quick uptake. One of the things that I don't have time to include in my talk, but which we are really proud of, is that in the midst of the pandemic and at the end of around an 18-month review process, we announced our CISE Expeditions in Computing Awards. And one of them was for an expedition on computing whose home is at University of Virginia in global pervasive computational epidemiology. So it feels like we were prescient, but I think it's really just the researchers had been working for a long time on this, and they have pivoted quickly to looking at COVID-specific aspects to what was their already sort of broad research plan. CISE was also, or NSF was also a co-leader in the formation of the COVID-19 HPC Consortium, which is now a partnership of around 4 different entities internationally that are contributing cycles and resources towards advanced computing in service of different COVID-related topics. And we're really proud of the fact that CISE, OAC-funded resources, are the single largest contributor of resources to that. 30% of the cycles, 46% of the projects are being homed by CISE, and we're super proud of that. We're always talking about ways in which networking has responded to the call and sort of understanding where we got through previous NSF funding and where we need to go. So the idea of networking broadly at scale is one important thing, and also broadband access is another thing. I mentioned the power test beds, which are one important angle on this. We also are doing a directed program called Overcome, which just got announced, I think, last week. Overcome is about sort of novel research on broadband technologies for underserved communities and for virtual learning in particular. So it's very much inspired by the situation we're in, inspired by the kids who are supposed to be learning virtually but don't have any internet access with which to do so. But from that inspiration, taking it as a researcher perspective.
Well, that's terrific, Margaret, especially about increasing access in these times. If it's okay with you, I thought we could do brief introductions. I think you know many of our colleagues here, but nonetheless, and I think it'll also be helpful to the audience to know who's here. So Xenophon, do you want to go first?
Hello, I'm Xenophon Koutsoukas. I'm the chair of the ECS department here at Vanderbilt.
Benoit?
I'm Benoit Duant. I'm a faculty member in the ECS department, and I'm also the director of the Vanderbilt Institute for Surgery and Engineering.
And Andreas?
I'm Andreas Berlind. I'm an associate professor of physics and astronomy, and I'm a co-director of the Data Science Institute here at Vanderbilt.
And Doug?
Hello, I'm Doug Schmidt. I'm the other co-director of the Data Science Institute here at Vanderbilt. I'm a computer science professor, and I also work closely with Padma in my role as associate provost for research.
And Doug, you don't know this, but I think your title says Dr. Margaret Martonosi, so I think you're trying to steal Margaret's thunder to give you. Must be a technical glitch. At least on my screen, you're showing up that way. So I was just going to, Margaret, if it's okay, I was just going to open it up so that we could start, sort of talking with you, posing some questions right here from the panelists, and also questions that are coming from the audience.
Great. I think I can start a related question to the COVID-19 pandemic, especially in the department with a lot of advanced graduate students. So in the past, NSF programs like the CRA postdoctoral fellowship program offer crucial assistance to advanced graduate students during crisis. With the pandemic making all these waves in the job market and the hiring freezes, are there any programs or plans at NSF to help keep our students in the field and cultivate the pipeline of new computing faculty to teach?
Yeah, great question. So while we were still, I refer to it as in the building, so it must have been early March. So the pandemic was starting to be known, but certainly long before its full impact had been seen. Conversations started about the likely need for an emergency postdoc program. And many of us remember the Computation Innovation Fellows, the CI Fellows program from 2008's economic downturn. So those sorts of conversations started in early March. we were able to turn that into receiving a community proposal to do such a program. We sent it through merit review, so external people reviewed it. We got it funded by late April, early May. They went through a set of applications with the deadline being in June, I think extended to early July because of some stuff, civil unrest that was going on around then. And they were able to announce in late July the first round of CI Fellows 2020 recipients. So I'm super proud of the nimbleness that NSF and CISE showed in response to what was a very pressing need. And I'm super proud of the community that also responded. Some of our reviewers had COVID themselves while they did their review. So that's the good news. We received hundreds, I believe it was over 1,000 applications, or I should say CRA, who was the point on this. CRA received over 1,000 applications for around 59 spots. And so we have, and we're happy that those 59 are in place. They have 2-year postdocs. And we did an elaborate max 2 approach. So the postdocs, no more than 2 could come from any PhD granting school, and no more than 2 could land at any particular postdoc home. And with that max 2 approach, those 59 postdocs cover, I think, nearly 50 universities. So this is not just a few universities swapping back and forth. This is a very broad impact on our field, and I'm really proud of that. We did that, if you think about the flow of the fiscal year, coming up with a postdoc program in April is basically looking in the sofa cushions for spare change, because most of NSF money has been committed in some way or is intended to be devoted to funding programs. So this is what we could do with the resources we had this year. And we certainly hope to be able to look at next year's budget and do this again, assuming that it's needed again. And we'll have to see what resources are available for that. But it is very important because you don't want a long-term gap in our field because of something like this. Yeah.
I must say that it's a very rapid response to corral, the community together and handle the reviews of these thousands of applications to down select to 59. It cannot have been easy, but it's terrific that you were able to place these 59 people across a variety of disciplines.
It was an extraordinary response. I'm really proud of the NSF side of it, and I'm really grateful to the community side of it as well. It was extraordinary.
Questions?
Yeah, as director of the Institute for Surgery and Engineering, a lot of our members get funding from the NIH, and some from the NSF as well. In the past, there had been programs, joint programs between the NSF and the NIH. Now, I'm kind of wondering if this is a model that you favor and that you would like to push in the future.
That's a great question. So I can answer about partnerships with NIH in particular, and I can answer about partnerships more broadly too. So we do have several programs where we partner with NIH, including Smart and Connected Health, for example, where there are sort of areas of overlapping interest. And we have every intention of continuing that as much as we can. If you look across the CISE portfolio, I think CISE is extremely forward-looking and entrepreneurial about partnerships in general. So the AI research institutes, whose rollout last month I mentioned, are the result of a strong partnership with the US Department of Agriculture in particular. So $40 million of that is USDA, and we're very grateful. And that in turn is the result of years of partnering with USDA in other efforts before that. So these things are very relationship driven, as you know, as you can imagine. So you don't just sort of poof $40 million worth of partnerships. It comes from partnering on CPS, Smart and Connected Communities, and so forth over the years. So we have, I think, every hope of continuing and broadening those partnerships. As you know, we have a new director at NSF, Dr. Panchanathan, and Panch is extremely vocal and positive about the role of partnerships, both for the resources that one can leverage through partnerships, but also because it helps bring researchers in close contact with important topic areas, important problems, important data. And so this notion of partnerships for reasons other than just money, I think, is an important thing to stress when we look at many partnerships. It's about the interesting problems that industry or agencies bring to the table, and sometimes the data that they bring to the table too. Thanks.
Thank you.
So this is Doug Schmidt. I just have a quick question. You talked earlier about expanding the workforce to broaden participation through the inclusion programs that NSF is supporting. There's obviously a tremendous demand for other more near-term retraining or training of the workforce to do computing. Is NSF doing other types of things? For example, helping people from other disciplines get retrained to computer science. We have lots of people in our data science institute, for example, who come from other fields, and they're trying to retrain themselves after the graduate level, after the undergrad level, to try to get back in the workforce. Are there other things that NSF is doing along those lines?
So that's a great question. So I think one of the things to keep in mind, as you know, is when it comes to things like harnessing the data revolution or the AI institutes, those are both examples of very broad multi-directorate programs at NSF. And so we are often seeing very interdisciplinary kinds of efforts. The NSF Research Traineeship and RT program is an example of something that's specifically aimed at these kinds of interdisciplinary, not retraining, but bringing people into unique grad curricula that span different areas. And we're also sort of working hard to explore what are the best ways to make sure that our booming undergrad enrollments understand and appreciate the opportunities that grad school offers to them. Because I think we're kind of unique relative to the other STEM disciplines in terms of massive undergrad enrollments, relatively few of which are actually going into our grad programs. And so looking at fellowship mechanisms or looking at mentoring mechanisms, looking at expanded REU mechanisms to help people see when that kind of pathway would be of interest to them. Thanks.
Thank you.
I have a question, if I can go next, that sort of relates to my personal status as someone whose main directorate is not CISE. It's a mathematical and physical sciences. But given the interdisciplinary nature of a lot of this work, computing and data science in particular, sometimes it can be confusing to PIs like myself to know which programs to apply to. And so my question is, so specifically, are CISE programs open to investigators whose primary field is not, computer science, but is one of these application areas like physics or chemistry or economics or something like that? Or are those investigators expected to stay within their directorates? And maybe another way to say the question is, how often do you fund non-computer scientist PIs with CISE programs?
So I think the short answer is, we don't sort by what department you're in. We don't sort by what degree you've received. We do seek to sort to some degree by the topical match of your proposal to the program. Some programs span multiple directorates. So for example, our Quantum Leap Challenge Institutes span math and physical sciences, SISE, and engineering. And proposals can come in across a broad swath. Harnessing the data revolution is an example of an NSF big idea that is co-led by SISE and math and physical sciences and accepts proposals across that full swath. So I think high order bit is it's the topic area that is what we seek to match. We don't sort based on your department. And I don't actually have the numbers on the departments, but I would guess that CISE is an extraordinarily broad set of departments these days, and increasingly broad, partly because of data science, as you mentioned, and sort of bringing in those scientific disciplines that are applying computational techniques. Also because of information science and the iSchools that are often sort of as large as computing organizations on campuses, and yet pull in other disciplines as well. Statistics, applied math, mechanical engineering, electrical engineering. I'm just sort of enumerating on some of these virtual campus visits. I've had, a half a dozen departments there in the Zoom. So that diversity of topic areas is a present and growing aspect of what we do. And then kind of more pragmatically, what I always tell people is, especially sort of early career people who are trying to navigate this, is every NSF program has a set of program officers listed on the NSF webpage. There are things about our NSF webpage that I would change, trust me, but it does have the names and the contact information for every program officer for every program, and they are on the whole extraordinarily accessible. So if anyone has a question about, I have an idea XYZ and I'm trying to decide whether to send it to this program or that program, the NSF program officers are really good at helping sort that out, and they're quite accessible. There might be some program officers that when you email them, for some reason, they don't respond right away. But on the whole, the response rate is high and quick. And, back in the day, I would encourage people to go in person and meet some of the program officers to have a more human relationship. Right now, there's an awful lot of telework happening. So you're not going to meet in person. But on the other hand, I think it's easier than ever to say, hey, I have a couple ideas. Can I run through a couple slides with you by Zoom? And I think most program officers would welcome those kinds of emails and asking for, say, a 30-minute Zoom. And they enjoy hearing what's new and thinking about how to sort it. And they are extremely good at knowing how to sort it, knowing how to sort of match it to the typical panels and the typical expectations of different programs.
So another question for the interdisciplinary work is related to the broadening participation in computing plan. So our department, we're preparing the plan, we participated in the workshops, we are pretty ready. This is a very important issue at Vanderbilt. But we see that probably the most promising activities here at Vanderbilt are interdisciplinary. For example, with collaboration with a medical school in medicine, or in cyber physical systems, or in data science. So we're trying to understand how to navigate broadening participation in computing with including interdisciplinary activities. Do you have any advice for us?
I think that's a great question, and I can give you the Margaret answer. And I think the Margaret answer is also the CISE answer, but I think as recently as maybe a year ago, there hadn't been a real deep consideration of what does a departmental BPC plan mean to the stats professor on a campus, or the medical school professor who's doing a lot of data science, or the mathematics professor, right? So I think the way I view that departmental BPC plan is it's BPC, and so it should have computing relevance as its core. But I see it more as a campus BPC plan, which is to say it may be led by the computer science school or faculty, but I see no reason to systematically exclude the mechanical engineer or the statistician that wants to couple into these areas, that intellectually links to these areas. So that's part of like who can partner into the plan. The second thing is about what the plan talks about. And there, I think the plan can and should talk about anything that is computing relevant, and where you, as the CISE relevant faculty, feel that you have some reasonable amount of agency and control to help make it happen. Like, so saying that you're gonna do something, saying that the medical school is gonna do something wouldn't be very credible, but saying that you're gonna work with the medical school to do something and having some confidence that it's something that you can make happen, I think that's very credible. And it gets to this notion that we're a broader field. We reach out in many areas, and I think that's in many ways one of our poles, right? That's how we're going to diversify in many cases, is by thinking about our field more broadly. And so I would hate to take that off the table.
Thank you.
So if I jump in now, one of the questions from our course, our faculty, is around the impact of sort of recent immigration restrictions on sort of, foreign graduate students. As you know, we have a large number of them, and many of them stay on in the country, like yours truly. And so we just sort of wanted to ask you and sort of get your thoughts on that, or NSF's position on it. And are you seeing any impacts in regards to the projects that you're funding?
Yeah, so there's a lot of different layers to this. So let's see. I think where NSF has been allowed to give out budget flexibility. So let's talk about different layers in different ways. Okay, so one layer is I personally have some graduate students who decided to go home to Spain and to Greece because they felt more comfortable there. And if it's all going to be remote, why not? And so there are budget flexibilities around, can you fund people if they're existing ongoing students and they're remote? And I think those have been sorted out. NSF has tried to give as many of those flexibilities as possible, subject to whatever guidance we get from the OPM, the Office of Personnel Management, right? So that's one. The second thing is about incoming graduate students who are foreign, and there's a challenge there of the initial sort of visa process. And I recognize that that's challenging. In general, I think there is some discomfort about paying people out of NSF funds before they have gone through the visa process. And different schools are navigating that in different ways. Many of our schools, for reasons completely separate from all of this, would put students onto fellowship or TA-ship at the beginning to avoid having them be on research funding too early in their process when it's not clear that they can be very research productive. So then there are the other issues that have to do, say, with science and security, either concerns or questions or rhetoric. And I think that's a very complicated topic area. I think the way I view it is that we are a field that is deeply international. I am not just the kid of an immigrant scientist, but I'm actually the kid of an immigrant scientist refugee. So my father left Hungary in the aftermath of the Hungarian Revolution. So I think this is personal for a lot of us. And what we feel is that many of us are just deeply passionate about the science, don't know who's citizens of where, and we're just about the science. And then in the midst of that, there are a few bad eggs. And I think it's a small number, but I think we as a community need to acknowledge that there are some. And the question is how to navigate the bigger picture in light of that. NSF funded a report by the Jason's group about a year ago. And the report, so Jason's is a group of researchers that typically do research, classified research on behalf of different agencies of the US government. NSF asked them to look at science and security issues. And you can read their report, it's public, and you can read NSF's response to the report. And I would encourage you to do that because I found it, I personally found it very reassuringly sort of measured in saying that the value of open research is extraordinary. The value of collaborative research is extraordinary. The JSON's report acknowledges the degree to which US scientists collaborate with a rich number of other countries in their work, you know, the co-authoring rates and so forth. So I think there is an awful lot in the JSON's report and the NSF response to it that people will find reassuring, and I would encourage people to read that.
Thank you, Margaret. I think it was really great that you could accommodate any kinds of extensions for students who are already enrolled in programs, and we'll certainly be looking at the JSON's report, you know, in more detail as a community, because it's also giving us some guidance in how universities frame, you know, how we operate in this world. When, you know, when there are serious issues involved around both protecting collaborative research as well as protecting sort of the intellectual property that comes out of it. So thank you for that. Other questions? I know that, let's see, Andreas, Xenophon?
I think I have a question, and I am going to change a little bit the subject. I know your interest in policy and other kind of impacts of computer science. So, I mean, Vanderbilt is a liberal arts university. So we have a lot of discussions, and we think very deeply about what is the role of computer science in a liberal arts university, and in creating kind of opportunities for our students reaching beyond technology. Any kind of advice for us or any thoughts?
Sure. So that third theme of mine on the socio-technical frontier hopefully gets to some of that I think as a field, we should not just accept, but be really excited about the degree to which we are societally impactful and the degree to which we permeate so many different aspects of the world these days. And so if that's the case for us and our ideas, then it makes sense for that to be sort of reflected in universities as well. I think it was very heartening. So I'm a Princeton professor. Our president was an undergrad physics major at Princeton who became a constitutional law scholar. So he has some tech in his background, but it's not his main focus as a scholar. So when he wrote an op-ed piece about 5 years ago about the centrality of computer science to liberal arts education, you can just imagine what the CS department, the joy that we felt about having our president write that, because Princeton has been a place where, you know, when I got there 26 years ago, CS and engineering were both literally and metaphorically on the outskirts of campus. And so to sort of have us move into the middle is a big deal. And I think it's something that we're seeing in a lot of schools. The downside to it are these booming enrollments, right? So the centrality means that everyone wants to take our classes, and that's challenging to navigate. But at the same time, it means that there's tons of appreciation for what we do. And I think that's important. So things like digital humanities and understanding kind of the social sciences aspect of our field are going to be increasingly important. And I think we as a field need to make sure that we are appropriately welcoming of all this stuff. I worry about discussions where we try to draw the line of what's real computer science or not. And I'm sure that all of us have been through some hiring discussions where someone's tried to draw the line about what's a real computer scientist and what isn't. And I think given our centrality to the field, to the world overall, drawing those lines isn't maybe the best use of our time. And so I think helping students see how richly connected we are to the rest of societal impact is one big thing. A second big thing that I will put in here, and it's where I kind of get agitated. I want the world to understand that we are not just coders, and I want the world to understand that we are not just the companies whose software they interact with the most, right? So I think it's extraordinary that I can sort of walk around with these devices and interact with the world thanks to Microsoft, Apple, Google, Facebook, and so forth. But I want the average American, and I'm sort of looking out my window at my average American neighborhood, I want them to understand that behind Bill Gates, who left his degree early, and Zuckerberg, who left his degree early, and Brin and Page, who left their degrees early, and Jobs, who left his degree early, and so on and so forth. Behind all of those people who don't really have a strong academic identification in my neighbors' minds, behind all those people is extraordinary long-term research. And I would love for our communities and our neighbors to appreciate the long-term investments that got our world to the point where computing can have the pivotal impact that it has. So it's the CSTB tire tracks diagram, but it's also us being able to tell the story of our own research paths and the impact that they have had over the years. And so that's why I ask for the highlights that I do, because I think it's very hard for anyone to appreciate why we should pay for anyone's career award or anyone's anything until they understand that the mosaic of those career awards has gotten us to where we are now with so many benefits from them. And they tend not to see the long-term research investment that helps with those benefits. They tend to see the commercial add-on at the end.
Thank you.
That's as agitated as I get.
Well, I mean, you're making a very great point, and that goes to the video you showed, you know, from Adve, from Professor Adve at Illinois, right? Because that whole platform was the catalyst for the technologies that have given us the apps in our cell phone. You know, we don't need to become a systems engineer overnight. You know, our system gets upgraded and we have new apps at our fingertips. And I think mapping out those trajectories is really important. And I think it's hard to point to, right? Because it's not the thing, it's the software. It's all these other sort of technologies that you don't touch that keep changing over time and yet make so much possible. And I think from what you're saying, I think this is part of what we should be undertaking as educators. You know, as we educate the next generation of students, I think they need to see what these long trajectories look like and how they could be influential at many points along these careers. So I think that's a terrific point that you're making. I'm looking at the time, and I think we might be right at the point where we may want to move into the next part where we are focusing a lot on early career researchers and graduate students and postdocs and faculty. But I think we still have a minute left for sort of one last question or a comment.
Can I take one?
Yes.
You know, nowadays, programmers and data analysts have an enormous impact on society, right? You can write a few lines of code and impact, you know, millions of people. I was at a academic leadership for Data Science Institute meeting last year, and it was sort of discussed quite a bit whether there should be something analogous to a Hippocratic Oath for data scientists. You know, do no harm. And you could say the same about computer science. I thought that was kind of an interesting idea. Do you have thoughts on this?
Yeah, that's a great point. So first of all, CISE has the Q program, Computing Undergrad Education program. And Q seeks to encourage 2 to 3 colleges to join together in revamping their curriculum. And there's specific supplements to encourage consideration of ethics within these undergrad curriculums. So that's one aspect to this, which is at the very beginning, not just for the people who are going to be in research careers, but anyone who's going to sort of be in this world, to be exposed to ethics early. I think the other aspect of it has to do with the ethics of the technologies we produce. And I think that's a much harder question to answer. It's a question that I get asked, frankly, by congressional staffers and so forth. They're worried about this. And in particular, we as a field don't always give the impression that we're worried about it. So I think step one is for us to feel more vocal about acknowledging the ethics concerns of some of our directions. Step two is to try to sort out as a field. There's often sort of dual use aspects to our work that there's a million wonderful things that I could do with face recognition. But then you could also misuse face recognition. And you can come up with that for so many different things that we do. And so we can't hold researchers accountable for what happens with their idea and steps later. But I would love to see researchers, I think, more willing to take on some of those questions of what the different pathways might look like, and to think about it. And so I don't know whether it's a Hippocratic oath that's sort of written into pressing the submit button on an NSF proposal, but I would like to see our community through our professional organizations think about these ethics issues more broadly. I mean, getting back to the international question from a few minutes ago, one of the concerns I have is that the international question usually sort of gets wrapped up in issues of ethics and security, when we should really acknowledge that there are ethics and security issues that are largely independent of citizenship, right? And I would like to see our field focus on those broader ethics and security issues, and Hippocratic oath or other ways of sort of thinking through the ramifications of what we do. Because I think it will benefit us in the long run, both in terms of sort of focusing our resources on things that are more likely to be beneficial. It will also benefit us in terms of how the world views us. If we look like a field that doesn't think about ethics or doesn't care, I don't think it helps us in the long term.
I think that's a terrific answer, and just very thoughtful, especially in sort of, you know, elevating the science and security question to something far bigger than that and applying very broadly, and not just around sort of the international question. I think it's something I had certainly not thought about, but I think that's just the right way to frame it. So let's see, I think we are at the 3:30 mark almost, and we were going to kind of switch over pretty much in the same format, but then where we focus a lot on early career researchers and questions from the audience around that. I know that this is a passion for Margaret. I think she has been a champion in the community trying to broaden participation and mentor early career researchers to be successful throughout their long career trajectory. And I think this will be great to have some questions and see what Margaret has to say about some of the questions that come up. So Margaret, is it okay if we just field you questions from the audience?
Yeah, that's great. Bring it on.
So I can ask some of them. There's a question from someone about whether research track, so non-tenure track faculty, are eligible for career grants.
My answer is always that you should check the program page. My memory is that for career, you have to have some teaching component to your work, because there is this curricular aspect to it. So you don't need to be tenure track, but you do need to have a teaching component to your work. Okay. And the career FAQs can sort of sort that out.
Thank you. There's another question from one of our new faculty about this change where you can apply at any time of the year. So the question is, are there any budget allocation limitations for the CISE course small grants based on time of year? In other words, if waiting to submit a proposal in the spring as compared to the fall, is it less likely to be funded based on most of the budget having been allocated earlier?
Great question. So, and I've done about 24, almost 36 of these virtual campus visits at this point. And normally we're kind of all in one big Zoom together. So there's 50 little boxes staring at me. This question always gets asked, and there's about 3 more questions related to the no deadlines that always get asked as well. CISE went to no deadlines informed by our experiences with a pilot that we did for the Secure and Trustworthy Cyberspace, the SATC program. And we're also informed by the experiences of several other science directorates that went to no deadlines ahead of us, including engineering and bio. And so a lot of what we are planning to do is informed by that. I will say that we know of no reason why you should try to game the system to submit earlier or later in the year. The basic plan that we have is that the very sort of the most clear-cut, great proposals out of a panel, we will award. The most clear-cut, in need of improvement proposals out of a panel, we will decline. Some of the middle, we might carry on for a little while longer while we see what else comes in. But in general, the best practices that have been developed for all the no deadlines programs within the foundation encourage program officers to give out money steadily. Don't wait for the end. And so we do not expect to have any sort of best time of year to propose. And there's a question that often gets asked around now that I will just answer, which is CISE has had a 2 core proposal per year limit. And how does that work in a no deadlines world? And this actually was several meetings worth of discussions, right? So what could we do? We could say that it's 2 proposals per fiscal year. And when the fiscal year ends, that's when the 2 resets. But guess what? If you say it's 2 proposals per fiscal year, then implicitly you're saying that September 30th is the deadline for core smalls. And so we've sort of ruined the whole no deadlines idea. So instead what we're doing is it's 2 proposals per year for you. So if you submit a proposal in December, say you submit a proposal on December 1st, 2020, and you submit another proposal on January 2nd, 2021. That means that you can't submit a proposal again until December 2nd. So basically you maintain your counter, and when a year has gone by, you can decrement. When you submit, you increment, and you can't submit if your counter is at 2. And then the last question that gets asked related to that is, let's say that I'm doing a core small with my colleague collaboratively. When are we allowed to submit? And the answer is when you are both at a point where you are each individually able to submit. So if you submitted a proposal on December 1st, and you're not eligible again until the next year at that time, but your colleague isn't eligible until even later, you have to wait until you're both eligible. So as you can hear from my explanations, this is something that I think should be very beneficial to the PIs. It's also fairly intricate for NSFers, the program officers and the administrative staff to oversee. And so I think while many PIs have expressed some relief about not having to deal with core small deadlines, and they've thanked me for that, I would encourage you to thank the other NSFers in your life, because they're the ones that are taking on some work in this. We're benefiting from tools that other directorates have developed, and we're doing some tools development of our own to automate this, but it will still be more work for NSF, but we think that it's worth it because of the technical nimbleness. We think it's going to lead to better proposals because they'll be submitted when they're ready. And we think it'll lead to proposals that are more responsive to current events. Thanks.
I have maybe a follow-up question to this that relates to proposal submissions. Do you see a trend where PIs are resubmitting their unfunded proposals again and again, and thus sort of ballooning the total number of proposals in the system? I know we see that in MPS.
So we're keeping the 2 proposal per PI year limit for the course.
So that helps.
And I'm a good experimental scientist, so I try to change only one variable at a time. And so we're going to no deadlines, but we're not changing that 2 proposal limit. There were other directorates that changed that limit at the same time they went to no deadlines, and that was not a successful thing. It wasn't good to change those 2 things at once. So we're keeping the 2 proposal limit. We're going to no deadlines. And we shall see what it does. I mean, one opportunity that it gives proposers is if you submit something and you find out relatively quickly that it was declined, you can use your second one of the year to resubmit, right? And so there's opportunities to sort of follow up on feedback, improve, and put it back in a more nimble way. There's also opportunities that if you get funded at a particular point in the year for the thing you really wanted to do, then maybe you don't need to submit the second proposal. Maybe you have what you need for a while. People, I think in some cases, were submitting up to the limit for the fall deadline because they knew it was their only chance for a year, and they kind of wanted to get as many, as many lottery tickets as they could, if you will.
Seeing a question from the audience from Professor Niamtu. He's the chair of our mathematics department. And his question is, does CISE support quantum computing and quantum information theory proposals? Are there special programs for this relatively new field? And I wanted to lob it to you personally, Margaret, knowing how much you're vested in developing this emerging area.
Thanks. Yeah, so the short answer is yes. There's a kid out there somewhere. Cool. So the short answer is yes.
That was mine,
so
sorry.
I mentioned the QCIS. I mentioned the QCIS faculty fellows. That's bridge funding to hire faculty. But then in our core, our algorithms cluster is funding quantum algorithms. Our Foundations of Emerging Technologies cluster is funding quantum hardware. The Expeditions in Computing program has funded a very quantum-oriented expedition about 2 years ago. And we would expect that this will continue, that all the places where quantum comes into the computer science world, it's definitely in scope, and we see it throughout our core. I don't know that any of the PPOS, the sort of scalable systems things, have talked about scaling quantum. I'm not sure that the PPOS program or reviewers are really mentally ready for that kind of technology to come in scope, but I would check with the program officers on that. And then obviously the Quantum Leap big idea continues to be, we're about halfway through the sort of initial 5-year timeline of the big ideas that were announced about 3 years ago. And so the Quantum Leap big idea continues to have a set of solicitations around it. And as I mentioned, those span between 3 directorates primarily. So CISE, engineering, and math and physical sciences together do these Quantum Leap fundings. Oh, I should also say that in addition to those kinds of funding, we also did a Dear Colleague letter about 4 months ago where CISE and MPS, our Math and Physical Sciences Directorate, together offered to fund supplements for any researchers who were interested in trying out their ideas on real-world quantum platforms and testbeds. So as you know, IBM, Microsoft, Amazon, and others are putting out cloud-connected quantum resources. And this DCL said, for the 3 major providers with whom we had reached agreements, you could talk to the provider, tell them what you wanted to do, get their approval, and then talk to your NSF program officer and get a supplement funded to pay for the resources to run on that provider's cloud-connected quantum resources. So in terms of kind of making quantum algorithms real and also broadening the set of people who are conversant in what these platforms are like and how to work with them, that supplement, I think, was a strong attempt to signal that we'd love to see more in the community get into this. Thanks.
I have another, I guess, 2 questions from early career faculty. So if there are multiple program directors for a single program, is it better to individually contact the directors or all of them? And what is typically the amount of detail needed when an early career faculty will try to approach some of the program directors.
I think there's some psychology research on the likelihood of getting a reply to an email, depending on whether you email it to people one at a time or in a group. So I might suggest that you email the group as a whole and see if they reply. And if they reply, and the normal case would be that one of them would reply, then you have your person to have that conversation with. If emailing the group as a whole doesn't get you a reply, then emailing one at a time a few weeks later might be a very reasonable follow-up. In terms of the amount of detail, I think that's very person dependent. And it's also a bit program dependent, because in some cases it'd be really easy to sort out what advice to give you. And in other cases, they would need to hear more about the ideas in order to, should it be this robotics program or that robotics program and so forth. So I would encourage you to sort of reach out with a relatively simple email and give the rough topic area that you're interested in finding out more about. And then in the course of things, a natural next step would be to have say a 15 or 20-minute Zoom conversation with them, where it might be reasonable to bring up a, say, 2, 3, or 4 slide summary, just to start the conversation and make sure they understand the context. Something on that level. Thanks.
There's a question about graduate students. So the question is that many PhD fellowships are focused on US residents and citizens. Is there a plan where the NSF will extend the scope of such scholarships?
Say that again. So
in other words, graduate student scholarships for international students. Is that at all discussed?
So I think one thing to keep in mind, so the graduate research, NSF Graduate Fellowship Program, GRFP, is ordered 2,000 a year across all of the sciences. Our field has vastly more graduate students than the 2,000 that is for all of the sciences. So while I appreciate GRFP's sort of wonderful role in supporting some small number of wonderful students, in my view, the big picture is the NSF support that comes through research grants and that funds the broader grad community. And so if you look at those numbers, I can go back to that slide, that's thousands of graduate students. I think it's sort of 6,000 or 8,000 graduate students a year that get funded through our research funding. And that is without a citizenship limit. So I think if I choose to sort of focus on the big picture, it's that we are supporting close to 10x more students through research funding than we are through graduate fellowships. And so I doubt that changing GRFP is likely to be on anyone's short-term plan. But the more important thing to me is making sure that the science as a whole stays open and inclusive. And I think right now our numbers would say that we are funding a broad range of students. Fair enough?
I'm seeing a question here that came a few minutes ago and I didn't notice, and it's from Regina Russell. She spoke about the fact that you'd mentioned that long-term research trajectories and disciplinary development has missed about 70% of the talent, and therefore it's biased in terms of sort of ideas, sets, and priorities and perspectives. And she wanted to know how you might frame the most important kind of blind spots in current CS theory and methods due to this skew.
That's a great question. I think we could have another 2-hour conversation about that. And I think we could all come up with a few. You can't tell, but I'm 5'2". And so most of the early airbags that were generated by engineers, automotive engineers, would have killed me. And I always have the hunch that if there had been a 5'2" person on the engineering design team of some of those airbag designs, maybe the answer would have been different. Maybe they would have allowed for a broader set of heights for which it was safe to drive in a car with a steering wheel airbag. So that's my sort of personal preface. We can look at this a few different ways. I think there's been some really rich and challenging discussions this spring about AI bias. Timnit Gebru and others sort of going into how much of that is because of the data sets, how much of that is because of the algorithms and so forth. So I would say that sort of sussing out some of those issues is probably one place where you could imagine that the science would be shaped differently depending on who's engaged in it. I think the issue of accessibility is an important one that maybe doesn't get as much conversation time as it should. Accessibility writ large and its role in the HCI community in particular. And I think that's a place where, you know, if we had more hearing impaired or sight impaired researchers in our midst, we would probably be taking different and broader angles on some of that. I think another way to look at it is in terms of certain topic areas, and it gets back to this conversation we had maybe half an hour ago about where do we draw the line, what's in or out for our field, how do we view information schools, and you know, the very large numbers of the women in the broader CISE community are actually in information schools rather than computer science departments, and understanding how to navigate that, both in terms of inclusion and in terms of what topics are we missing or emphasizing as a result of that, is probably something for our community to think about as we go forward. So that's an interesting question, and I would love, I don't know if she has the ability to answer in wherever she is in attendee land, but I would love to hear other people's answers to this. If you can't speak because of how Zoom is set up, feel free to send me an email. It's something that I'm sort of trying to hear more about. Thanks.
Thank you, Margaret.
There's one question that has to do with the review process. There is one frequent complaint about panels is that when you get rejected and you address the comments and resubmit, you get a different panel and different feedback. So is there any plan to change that process?
CISE actually did a small pilot a few years ago where it offered a response process similar to what some of our conferences are doing, namely letting the PIs see the reviews and respond to them before the panel actually met and made the decision. So that's not about the iterative aspect of it, but it is about a case of letting the PIs at least respond in one way at one point. It was a small pilot. I think the results were not super conclusive of that size of pilot. And the NSF IT systems are not easily changed. And so sort of bringing that in as a larger scale pilot hasn't happened. We're mindful of the fact that NIH has a different system. And in particular, NIH has this notion of study sections. So there is more continuity in the reviewers that you'll be working with for some period of time. So we're mindful of that. We watch that. And we also have watched, so NASA did a double-blind pilot, a pilot of double-blind reviewing a proposal, which frankly, as a proposer and researcher, it kind of blew my mind to even imagine. How would you write a proposal in a way that allows it to be double-blind reviewed? But they had a part that was sort of the science, and then they had a part that was the specifics relative to that research team and their university. And so there are some interesting opportunities there as well. I think the short answer is that the most likely place I think the shortest answer is that because we've switched to the no deadlines, we're going to let that impulse sort of settle through the system before we do any other big impulses to the system. After that, there are a few things on our mind. I doubt that the NIH study section approach is likely to happen. Responses, double-blind reviews are things that are more often in the conversation. Thanks.
I think we have time for maybe one more question before we wrap up. We're in the last sort of 6 minutes of this session, and I know that Dr. Martonosi has been extremely generous with her time at the end of what must be a very long day after a very long week. So thank you, Margaret. So one last question.
I have one last question. There seems to be a lot of interest in computer science departments potentially spinning off to computer science schools or colleges. Is this a trend that you see happening broadly, or is it just a couple of isolated examples that get a lot of press?
I think it has been happening broadly. I think it will be interesting to see, and I use interesting in the most trepidatious of ways. It will be interesting to see what happens over the next few years, because I think there were big plans for expansion and growth, and that interwove with plans to go from department to school of computing in many cases. And if universities are going through budget challenges that pull back on the notion of expansion and growth, it may cause the momentum around schools and colleges of computing to likewise pull back a bit. But I would say that in my experience, it definitely seems to have gone beyond the isolated cases and into something that's broader. And the biggest question mark for me is what parts of that can be sustained in an economic setting where so few departments, so few universities are hiring right now. I don't know, what do you think?
It's a great opportunity for some people to make investments. I think that's what I would say.
So I think this has been just a wonderful roundtable. Margaret, I want to thank you personally for being so generous with your time and supporting so many questions and such openness, bringing so much openness to the conversation. I want to personally thank you for everything that you're doing for our community in DC. It cannot be easy, but we need your help there. We need your help in growing our community. And I think this has just been such a wonderful opportunity to meet with you. We'd love to have you back sometime in person, but I think we'll all have to wait for a little bit before that's possible. And I want to thank all the panelists here for this roundtable and the audience, and also our terrific staff at Vanderbilt and the staff at NSF. So thank you, everyone. And what shall I say? It's TGIF. Thank God it's Friday. Thank you.
Thank you all. It was wonderful to get this chance to chat with you virtually. I agree. If we can get together in person sometime, I would certainly welcome it. I miss running into colleagues in the NSF cafeteria. Thank you very much. I hope your semester goes well. It certainly won't be a normal one, but I hope your semester goes well. I really appreciate your input and hope to see you soon. Take care.
Thank you.
Thank you.